I'm very excited to introduce Drew Luckenbaugh, who is coming to us, as you can see from the background, from KPMG, but is also going to be kind of carrying on the notion of really interesting artifacts you probably didn't know existed. And after you see this talk, you're going to say, "Holy cow! I cannot wait to go in and figure out how to do this in a more comprehensive, more systematic way." And the scalability with the tools that you've put into this talk here, I'm super excited about, because it's going to be something I think a lot of folks are going to get some use of, and you're probably going to get a lot of citations and forensic reports that we'll never get to read publicly. But that said, Drew is going to be not only talking about an artifact that you might not be familiar with, but also, like I said, an optimization that you can apply over the top of that, which will do wonders to bring in useful information out of graphical evidence, which you're going to get to see here. So without any further delay, I'm happy to turn it over to you, Drew, and tell us all about the bitmap cache and how we can OCR that thing into absolute value.
Thanks, Phil. Yeah, so hi, everyone. My name is Drew. Just a little background on myself. Last year, I graduated from Northwestern University as a student athlete, and I majored in computer science, and I played football there. Currently, I'm an associate at KPMG on the cyber response services team that's based out in Chicago. Since starting at KPMG, I've earned my GCFE and GCFA certifications. And today I'm going to be talking about, like Phil mentioned, the bitmap cache, an artifact that's not new, but after giving a brief overview of what it is, I'll discuss the new methodology and approach we've taken to quickly triage and pull useful data out of this artifact. So what is it? Well, bitmap cache are these small cached images. And from where you can see here on the screen, they're saved from your remote desktop session. So this was originally introduced to help with network bandwidth, as it allows for the reuse of images instead of having to constantly update the entire screen. Now, this artifact has withstood the test of time due to its interesting nature of visual analysis. Nowadays, 9 out of 10 times, the attackers will utilize RDP sessions just for how simple they can be, leaving this artifact behind. Some of those examples can be seen here, as well as a collage of them put together like here. So the standard size of a bitmap cache image are the smaller blocks here on the left, but then, like I mentioned, the collage put together is here on the right. Now, like I said before, it's not new, and it's been covered well in the past. It was introduced in Windows XP. It had a different extension, BMC, but now it has the extension .bin. And the artifact location has also changed in the Windows file system. But if you want to see where this artifact is enabled, just simply open up Remote Desktop, and you can see it under the Experience tab, and then Persistent Bitmap Caching. And it's that option highlighted in red down there. So this option is actually left on by default. So most attackers graciously don't take the time to turn it off for us, which is nice. So what does it tell me? Well, I've already alluded to this, as most attackers utilize RDP sessions during attacks. So this artifact provides a snippet of visual information that can really help you confirm activity you found in other artifacts. For example, if you only have the source host and not the destination one, you may not be able to confirm if an RDP session was successful and how long it may have lasted. The only evidence you would have is the outbound connection request to the destination host. So having that bitmap cache on the source host can help you view programs that were opened, any date and time stamps, files and folders, as well as really any other interesting information you might run into from the perspective of the destination host. So if you want to learn more about bitmap cache, feel free to check out the links on the bottom of this slide here. I linked a good article that gives a write-up on the full overview of bitmap cache, as well as providing the Microsoft documentation on how bitmap cache works. So let's discuss how to parse this artifact. Now, the best way is to use ANSSI's BMC tool script on GitHub. This Python script, it parses both the older BMC files and the newer bin files. And when you're done, it even allows for the option of putting them all together into one of these final collages you can see here. But in addition to that, it'll also give you a folder full of all these small bitmap images like this. Now, when it does this out of just one bin file or one BMC file, it'll work extremely quick, but you'll be left with thousands of images from just one single file. So one of the first questions you might have is, can I organize these images? A lot of them will be a part of a larger whole, just out of order. So if you're looking for some simple image editing, you could always throw them into Photoshop or Microsoft Word and drag them around in there. And this way you can try and piece the puzzle of them together and figure out which sections go together to create like a larger whole of an image. Or you could use some more complex tools that have already been developed. So previously, Brian Moran just spoke, Brian Moore Labs created RD pieces. And this script intelligently combines multiple images into a larger whole. And then BSI Bund also created RDP Cache Stitcher, which this provides a grid-like system of images to help combine similar sections together with ease. So I highly recommend checking out these tools and testing them yourself as well. Their GitHub pages are linked here on this page then. So moving on to the approach that we took, why optical character recognition? Well, in case you're not familiar with OCR, it allows for text extraction from images or other similar files. OCR is commonly used in e-discovery tools to create searchable text out of images that would otherwise have to be analyzed individually, image by image. But even so, on a smaller scale, it might be just as easy to look at images for information. So once again, why choose an OCR for Bitmap Cache? Well, let me provide you with the scenario that I was presented with. So imagine you have one host, one that was confirmed as the source host of multiple outbound attacker remote sessions attempting to connect to multiple unique destinations. Now, given that it was making so many outbound requests, this generated multiple 100 megabyte bitmap cache bin files, and that's the largest that they can get. And since you only have this source host, your job is to analyze each collage of bitmap images for any and all information that could help confirm the evidence you observed in the other artifacts. So below, you can see some examples here of how large these collages can actually get. And this is just 3 of them that came out of that one host. So where do you start? Do you have a methodology for searching through, or are you going row by row of bitmap images looking for anything? If you do find something, how are you going to keep track of it? Are you going to take screenshots, write down notes, try and highlight the part of the bitmap collage that contains the thousands of images? If a general approach isn't working, are you only going to look for the IOCs in the incident? And do you know what destination hosts you are even seeing the perspective of in these images? Is there an accurate inventory of all the hosts and IPs in the network for you to correlate the activity with? So these are the questions I was asking myself when I was in this situation. I wanted to make sure I didn't miss anything, as this was our only artifact that could confirm if the attackers successfully connected to the host they were trying to RDP into. Well, that's when the idea of the OCR Bitmap Cache script was born. So the goal of this tool was to quickly triage bitmap images on a larger scale. It's completely written in Python, and it utilizes the Tesseract OCR, so processing is done all local on your system. Since bitmap images are so small, text is usually cut off. To address this issue, the script intelligently matches a custom word list you provide it to the identified text. Then it outputs a CSV of the text it identifies, as well as a folder of all the images with highlights around the words it identifies. This way, it doesn't overwrite any of the original bitmap images and can show you what words or characters it is and is not easily picking up on. So next, I'm going to dive a little deeper into each one of these components and discuss how they work so you can get an idea of some of the screenshots down here and what they mean in terms of the script. So starting out with the CSV output, this is full of all the information that pertains to the OCR scans. It provides the path and the name of the original image. It provides the name of the output image. So this way, when you have thousands of bitmap images coming from one single bin file, it allows for an easy way for you to correlate the words the OCR identifies back to the original image. And then same thing with the outputted image file. If you want to see the words that identified in the outputted one, it also tells you that as well. Next, it then tells you the bounding box or the highlighted box size that it created around those words, so you can see where that positioning is. And then it tells you the words it finds itself. So it gives you the raw output from the OCR and the confidence the OCR has in that output. And then since that text could be cut off, like I mentioned before, it takes those words and matches them to the closest words that are in your word list to get you 3 other results that might be that word just cut off. So next, the next output is the highlighted image output itself. So these will be located in a destination folder that you provide the script as a command line argument. And then they'll be highlighted around the words or characters the OCR identifies. So an example can be seen here where the OCR was run on this entire collage. And then this red highlighted section here, if we blow that up, you can see that it shows the words and characters it identified in the smaller section of that collage. And the identified text then is all highlighted in green, so it makes it easier to distinguish from all the other information going on in the page. So this allows you to see, what words the OCR is and is not easily picking up on then. Continuing on then, to reiterate on the word list input, you can use any word list you want to provide this script, as long as the words or phrases are new line separated like any other common word list. This allows for customization to match any IOCs, users, IPs, really anything that might pertain to the specific incident that you're involved in. And this is helpful because then, that might allow you to filter easier in the closest matched words in the CSV output. Now, the script comes with a default word list, but customization is really a key part to tailoring specific results to your case and is a vital step to, increasing the accuracy of the output you get from this tool. So let's walk through an example here. Right here, we show an example of a section of a bitmap collage image, and it shows some activity related to ping. And below the image here, I'll walk through the script syntax and also the flag meanings. So to begin with, you have C. That's an optional argument that you can pass it. That is the minimum confidence level. So this can range anywhere from 0 to 100, where 0 can be every single result that the OCR identifies, and 100 would be, it would have to be fully confident that that's exactly the word or character that it identified. If you don't provide a C flag, it'll automatically use 0, so it'll just give you everything. Next is the source flag, so S, and that is just providing it a source image folder. So as long as it's being provided a folder full of images, that's all it accepts. D is the next input. That is the destination output highlighted image folder. So this will be the folder that it saves all the highlighted images to that I discussed previously. O is the CSV output file, and then W is the word list input file. So after running this through our OCR, our example image here shows that the custom word list returned a lot of results related to ping. We provided it one that was tailored towards ping itself. In the CSV output, you can see that there's multiple references like, ping itself, transmit, failed, general, even an IP address here. So just multiple references to, words or characters you would expect to see out of a ping command. And then below the CSV is the highlighted image that was outputted as well. And in here, you can see that it was able to successfully identify a lot of the information that was in it. Some of the cutoff text, it was still able to pull information out of and match up here. But then it also allows you to see some of the words that it wasn't able to pick up on as well. So this can help you a lot with, tailoring your results and seeing what data you're getting out of the tool itself. So if you're interested in utilizing or testing out the script yourself, the code can be found on my GitHub page under DFIR Drew/OCR Bitmap Cache. Please stay tuned on this page for any updates and improvements to the script. And if you do test it out, I'd love to hear any feedback on it and what you were able to use it for then. So speaking of improvements, I'm very excited to continue working on this tool, and here are some of the insights into what's next for it. So currently, the script takes the original image, then it grayscales it and inverse grayscales it for image preprocessing. So it then runs both of those images through the OCR to increase the chances of text readability. And so far, our testing has shown that this is the simplest and the most effective solution. However, there's multiple ways to improve the accuracy and reliability of an OCR. So even with Tesseract, depending on its version, it can read black text on white background better than it can white text on black background. So it just depends on the version that you're using. And that's kind of why we took the approach of grayscaling it and inverse grayscaling it so it can hit on both of those just in case. So next, we're also looking into ways of increasing image processing or pre-processing to help improve the readability of the text. So, just looking into any other methods that might be used in other mainstream OCRs for this. And then another improvement could even be involving piecing together multiple images by using some of the other tools I previously mentioned before throwing it through the OCR. That way it has more complete sections of images to begin with when it scans it. Now, however, one of the most effective current strategies is to tailor the word list to match each incident's IOCs and other valuable information or tactics that might be relevant to the incident you're using it on. Now, this is important given this tool's ability to match on provided values, since searching bitmap cache images can be scaled across all systems involved in the incident with this script. This allows for triaging across multiple hosts with just one run. And to further add to this, this script is not specific to just bitmap cache images either. It was simply just the inspiration for it. So as it is now, as long as you pass the source input folder as a folder of images, it can process any type of image that the OCR is provided and give you the same information as output. So some things I'd like to leave you with after this is really a new outlook on the bitmap cache artifact. Whether you've worked with it before and are familiar with it or not, hopefully it has you intrigued into what it is and how you can get some useful information out of it. This artifact is really relevant even today, as most attackers are still using RDP sessions to simplify their remote access and conduct malicious activity. It also provides context into the attacker activity in a visual manner, which is something that most artifacts just don't do. So it's unique in that aspect. Additionally, our script aims to simplify triaging bitmap cache on a larger scale, as it already has some great tools that have been developed for it on a smaller scale, but this will help streamline the process across an entire network or across an entire incident, for example. So once again, I just wanted to thank you all for your time and tuning into my talk. Feel free to connect with me on LinkedIn, and at KPMG, we're currently hiring. So if you're interested, definitely message me, and I'd love to discuss with you. Thank you again.
Oh, that's great. Thank you so much for sharing that, Drew. It's always fun when we've got a research coupled with actual tools that are released as well. So thanks for putting that out there. And I'd love to see your roadmap, because one of the big questions we get is that people want to contribute. They want to do things. So being able to see what those projects are and hear from the primary author is a great way to kind of get involved there. Let's see. So question that came in, and I actually hadn't thought about this when you and I did our run-throughs, is any methods for the libraries that you're using for the OCR functionality to extend beyond the English character sets, especially any of the glyph-based languages, I'd say would be pretty interesting.
Yeah, so currently, if you're familiar with Tesseract itself, it comes downloaded with usually the English language as one of its primary ones, and then it has some other default one as well, but you can install multiple languages when you download Tesseract as well. When it's passed through my script here, what happens is it just feeds in certain command line arguments that don't depend on the language itself. So if you wanted to, you could even edit the script to just target a specific language that it knows, or you could just leave it open and it'll identify anything the OCR itself has downloaded and is trained on then.
Okay, cool. And you bring up a good point with that, is because you didn't invent your own OCR functions here. You're relying on, going on the shoulders of other open source projects as well. You get all the added benefit of the work that's been done there and the continuing development that's there also.
Yeah.
And one thing I was hoping you could expand on just a little bit, you touched on it a bit, but when you and I were doing the dry runs, we talked a little bit about the methodology behind grayscaling, and you said that the utility is better with, I apologize, I can't remember, it's white text on black or black text on white. It's better in one of those. And we talked a little bit about the testing that you did. I'm basically saying, is it worth doing this twice in order to get better results? And I was wondering if you could expand just a little bit on the approach that you took and maybe some of the results that you saw in your test data.
Yeah, so originally, I started out with just trying to OCR the original images and seeing what kind of output would come out of those. But like we said, going from white text and black background or vice versa, the version of Tesseract actually depends on what it's built for. So it could be better in one aspect or the other. So we decided to grayscale it and then inverse grayscale it, because if an image on a screen has one text versus the other, this covers both aspects then. So that way we just pull results from both, just in case it could read one better than the other. And then, you have as many results as you could possibly get out of it. So.
Yeah, and I think that's a really cool thing too, that you're looking at in using those external tools and libraries, you see how they work better. And then instead of thinking, oh, great, I should fix that upstream library that, let's face it, we probably don't have all that much control over, even if it is open source, maintaining a fork's not easy. By being able to say, how can I and my component of this tool chain kind of overcome some of those limitations? And I think the approach that you took was great, which is that, hey, look, we'll double the runtime and we'll do this part of the process twice instead of going and modifying the actual algorithms themselves, which I think are really, really solid as well.
Yeah, definitely. And I think that's, one of the points I was saying for next steps, even, with image pre-processing, there's so many different ways you can do it with, different blurs or, filters or whatever. So really, this is one of the simplest methods to do pre-processing, but, there's tons of other testing that can be used to try and get even better results out of it.
Yeah, definitely. Super, super cool. Well, one of the comments that I don't think you had a chance to see that I thought you'd appreciate for sure, Ryan Chapman, who is writing our ransomware course, who we had on the panel during the lunch time frame, came on and he was like, holy cow, I've been doing all kinds of stuff with RDP for a long time and I've never done this before, and oh my gosh, so now I got to include something like this in the course. So
Awesome.
we're not committing them to it yet, but you may see some of these tools make their way into courses to give you an even broader audience of folks that can use it in their own casework, which is kind of the name of the game in the forensic world after all.
Yeah, that'd be great. Awesome.
So cool. Cool. Well, hey, thanks very much, sir. Appreciate it very all the work that you put into this, and look forward to more great things in both the tool itself, and hope to hear from you at these summits again too, because we know you're early in the career, which is great to hear that fresh look at things.
Awesome. Thank you, Phil.